Hello, my name is Alexei Konasevich, and you're watching Blockchain State. Today I would like to talk about databases on a blockchain. Blockchain, at the bottom line, is a kind of database itself. It stores transactions with cryptocurrency. However, its specialization doesn't let to use it directly as a general-purpose database, such as for developing non-financial software applications. To understand a bit more about the development of applications on the blockchain, I would recommend watching this video first. Here I explain the role of cryptocurrency and blockchain technology as becoming a public repository for storing arbitrary data. So today we're discussing how the feature of this technology that allowed publishing small pictures and messages and various even junk data on the blockchain that users could insert in transactions, how this feature can become useful for developing any dApps, decentralized applications, on a blockchain. Before starting, I need to clarify one thing. The following discussion refers to the original blockchain technology. The blockchain systems with Turing-complete smart contracts, such as Ethereum, are relevant to some extent. Methods of developing applications on such systems will vary though. But you have to keep in mind that it's not a problem at all for such systems because they are Turing-complete, which means you can natively develop on blockchain whatever application you want to. But it all started from the blockchain of the first generation, which wasn't meant for that. You might wonder why we need it if we have blockchains with Turing-complete smart contracts now. Firstly, applications on the original blockchain are not that limited as you may think. Secondly, for example, Bitcoin blockchain is the most secure and robust repository that you can imagine. This is because of its level of decentralization and scale of the network. And to be clear, no other technology that humankind has ever created can provide such a level of data protection. There are plenty of protocols and methods to develop applications and databases on Bitcoin. And I can mention Color Coins and Omni protocol. For example, stablecoin Tether operates their USDT tokens on Bitcoin network using Omni protocol. Not only on Bitcoin, but this network is one of their strongholds. One way or another, the approach that I will show you now is used in every non-Turing-complete blockchain platform. So, how does it work? As I explained in this video, you can insert a small amount of data unrelated to the cryptocurrency transaction itself into the blockchain. There are different methods and scripts for publishing arbitrary data, but normally you need to spend cryptocurrency because it gets published with a coin spending transaction. In Turing-complete systems, deployment of smart contracts and further transaction here also happen through spending cryptocurrency. So from this perspective, these two kinds of systems are not that different. So imagine Alice published some code on such a blockchain. She cannot include the whole program in there because it's limited in how much she can insert in the transaction. Besides, it's costly. So she decides to publish some critical pieces of her program, database entries of it, or a hash sum of it, or a hash sum of her program itself to ensure its authenticity. Now imagine other users of the blockchain. Everybody can see this data, but it's unlikely they can understand it. It's just some binary code, besides not the whole program, but maybe some critical variables. So when Bob finds this transaction on the blockchain, it doesn't make sense to him. Then Alice decides to describe what this means, and she writes it in the form of technical protocol, and she can even publish an open code of her application for everyone, say on GitHub. Bob can install this application on top of his blockchain node, as well as Alice did it. The application will extract data from the blockchain and interpret what Alice designed in her protocol. Now Bob sees that Alice created a token on the blockchain. Bob, Dave, and any other user will see these coins when applying this protocol to the blockchain. They can even publish their own coins using the same protocol, while all other users who use just a standard core wallet application will find just a chunk of code published inside of the cryptocurrency transactions, which doesn't make sense to them. So the protocol has two basic tasks. First, it establishes the data format. It explains the overlay system, how this data looks like. Secondly, the overlay application scans all forthcoming blocks and searches this data, and if it corresponds with this format, it applies some logic to it. And the data which doesn't correspond with this format will be ignored. So that's why Alice and Bob don't care, for example, if they've published some junk data on the blockchain. Their application will just filter it out because it doesn't correspond with the agreed protocol. When it does, the application picks this data up and adds it into the database, or performs some program logic that has been designed in the application. And to be clear, this happens on every node which applies this protocol. Alice will see the token on her computer that she created, and Bob will see it because he applied the same application. All others can see something inserted in one of the transactions on the blockchain, but they will not be able to interpret it unless they install the same protocol. Here come a few interesting conclusions. Public, permissionless, uncensored blockchain can be used in private applications. For example, Alice and Bob agreed about the protocol but didn't make it public. So they can publish whatever they want to. They can even encrypt the data to protect it. And the second interesting conclusion is that they don't care about any other transactions on the blockchain. They pay no attention to any data, even junk published by other users. So when someone says private permissioned ledgers solve these problems, you see, there are no such problems on a public blockchain in the first place, because there are two different levels of interaction. The first is the blockchain consensus protocol, where nodes create new blocks competing with each other, and as the result of it, it gets synchronized and they get the chain of blocks which is synchronized across the network. The second level, the user application level, and nodes have nothing to do with this. They just accept transactions and the data that users inserted there. By the way, each node acts independently, so any node may decide not to accept a transaction that contains some scripts and data. But because there are many competing nodes, and it's open competition, the user can send it to any other node and the user can mine the block themselves. But what if all nodes in the blockchain agree to the same protocol and logic of work? For example, they accept only one type of transactions with one type of data, and they don't accept others. This is how most of the blockchain platforms work. NEM, Cardano before they introduced smart contracts, Amercon, Waves, Other, you name it. Interestingly, when we experimented with one of the blockchains, we figured out that we couldn't send a transaction that wasn't compliant with the platform's standard. Other nodes just didn't recognize the format and didn't accept it. Still, we could mine our block, and in this block, among other transactions, we published our transaction which was incompliant, and other nodes didn't accept it. But they accepted our block because it was compliant with the blockchain protocol, and so they accepted it. It happened exactly because what I explained. Blockchain consensus protocol has nothing to do with the user application level. So technically, all these blockchain platforms are just blockchains with cryptocurrency in their bottom lines. Everything else is superstructure above the consensus protocol, even though it works seamlessly because it is embedded as a part of the node architecture. It works by the convention of nodes, by their social consensus, not as part of the blockchain protocol, as some may think. Now let me show you one of the database designs I came across, and I think it's one of the best in the industry, even though it's not well known. It was designed by the team of Emercoin Blockchain in 2014. It's an overlay key-value database. It is designed natively in the blockchain core wallet, so users can publish their data on the blockchain as a part of their user experience with it. Like a normal key-value database, where the key is a unique string, an identifier, and value which can be any user's record up to 20 kilobytes. Most of the blockchain platforms actually use key-value databases, and it's also used in DLT frameworks such as Hyperledger Fabric. They call it collections, by the way. But this project, first among others, went far beyond and implemented the full-spec database where users can create records, update them, transfer them, and delete them. So here is how it works. First, the user publishes her pair. Say Alice wants to publish her telephone number. As a key of the entry, she inserts her name, Alice, and as a value, her number, telephone number. There is another field, period. It means that how long the database must remember her record. It can be 1 day or 100 years or any other time. But the longer the time, the larger the fee becomes. This is how the system protects itself from spam. Smart, isn't it? When it gets published, the right part of the system scans new blocks, catches all compliant transactions, and inserts them into the database. And because it is a standard database, in this case they use Berkeley DB, Alice can use it in any application. She can create an application around it, as a database is a building block of any application. How does the system ensure that there are no other records with the same key, Alice? They employ two elements of protection. The first is that the wallet in which you create the transaction before letting you publishing any data checks in the database if there is any record with the same key. If yes, it will not let you publish it through. And as I said, we experimented and managed to create our own block, and because it was valid in terms of the original blockchain protocol, we propagated it in the network. But there was a transaction containing the record that wasn't compliant with the rules, because we were trying to create a record that someone already has published in the database. Nodes by convention wouldn't let us publish it, but because we created the block on our node, the block was valid itself and it went through. But then enabled the second layer of protection. The protocol didn't pick this record up to the database, exactly because the database already has the record with the same key. Neither our node nor other nodes in the network included this invalid entry into the database. What if Alice wants to update this record, say to change her telephone number? She creates a transaction with the same key but a new value where she puts her new number. The node which is going to publish this transaction sees that her transaction contains the key that has been published in the database, but because that record was attached to a coin, the system can identify the owner the coin is attached to an address, and because Alice has the private key to this address, when she publishes an update transaction, she digitally signs it as any blockchain transaction. So the system sees that she is the legitimate owner of the database record, and so lets her send it through. She can also update the period. If Alice initially published it for 1 year, at any time she can publish a transaction with a new period, say +3 years more. Alice can also transfer this record, for example, to Bob, to his address. So it can play a non-fungible token role. Besides, this record can be used as a payment alias. It is more convenient than a normal cryptocurrency address. A payer just needs to remember Alice, her name, and use it as the address. The system will search in the database addresses with the key Alice, and when it finds it attached to some specific blockchain address, cryptocurrency address, the system will send the coins to this address. And eventually she can decide to delete this record. She publishes the key with no value. So the system understands it as a delete command and erases the entry from the database. You see, even though the blockchain is immutable, it doesn't mean that you cannot build a logic where you can update and delete user records. On the left side is the blockchain, an append-only type of storage. It plays the role of the logbook. It stores all data and never deletes it. It's immutable. On the right, it's a dynamic part, and it reflects the current state of affairs in the database. You don't need to delete records on the blockchain. You just attach new ones which reflect updates. Because blocks preserve their chronological order, only the latest record reflects the current state of affairs. Others play historical reference. This is the most robust database that you can imagine. Whatever happens with the database on your machine, it's highly unlikely that the blockchain network will be destroyed. The one who wants to attack it will need to erase all the nodes of this blockchain on Earth, which for sure is not easy to do if you build your database on Bitcoin, for example, or any other highly scaled network. So once you lose the database on your PC, or you lose your computer, you will download the blockchain, and because it stores all the chronology, your machine will scan all the blocks from very beginning and recreate exactly the same database which you had before. And all other nodes will independently do it on their machines. With this database, in fact, you get what is called a decentralized application. In centralized programs, the owner of the app who runs the server can change anything on the go and propagate it among the clients. The users will get the changes, whether they want it or not. While in dApps, the users should agree in the very beginning about all the rules, including how they update their program. If Alice decided to change something in her protocol, she can apply changes only on her machine. If other users don't know about it and don't install the same update, they will use the older version of the app. Bob and Dave will see the app which they initially downloaded. They will end up having different logic of the program. Alice will see one thing, Bob and Dave will see another. That's why if they're building a decentralized autonomous organization, in the very first version of their protocol, they should develop an algorithm of how to make decisions on changes and propagate updates that they will possibly need in the future. We'll talk about it in one of our future videos. By the way, don't forget to click subscribe. So that's it for today. In the future, I will talk about how to create a land registry and digital identity using the database on blockchain. I also would like to devote one of my videos to Emercoin blockchain in their name value storage system, because they created an interesting ecosystem of services on blockchain, such as decentralized domain name system. So if by the time you're watching this video I've already created the mentioned videos, you will find them at the end of this video and in the description below. Don't forget to hit like and subscribe. This will help this channel a lot. Thank you.